Greetings everyone, how do you do? First of all, let me introduce myself. My name is Andik Santoso. I work in the PT Pembangkitan Jawa Bali as a boiler engineer. At this conference, I'm going to present the study conducted by me and my colleagues about effect of heat input in dissimilar metal welding on stainless steel 304 joined with T22 all steel to study the hardness distribution and delta weight content using the gas tungsten arc welding process. As a background for this study, dissimilar metal welding is a common practice in power plants, such as joining superheater boiler tubes using the austenitic stainless steel joined with the lower steel. The higher temperature and pressure are using the austenitic stainless steel due to the excellent characteristic, while the lower temperature and pressure are using the lower steel. This practice are conducted to the economical reason. However, different characteristics such as microstructure, chemical composition, or thermal coefficient makes degradation in the fusion zone, creating some residual stress. This condition makes welding joint susceptible to failure, such as crack. There are several methods that proposed by previous study to reduce problem in the MW, such as the prediction of chemical composition, buttering of base metal, controlling heat input, and reduce residual stress by heat treatment. This study is focused on the variation of heat input effect to hardness distribution and delta weight content or FN value in the MW. The method of the research is observing the chemical composition, macroscopic evaluation, metallographic or microscopic evaluation, hardness number, and Ferrite number. Specimens used are common boiler tubes, that is outside diameter 63.5 millimeters, thickness is 5 millimeters, length is 150 millimeters. Joint are T22 low alloy steel or 2.5 chrome with 1% molybdenum joined with stainless steel 304 or 80% chrome, 8% nickel. The welding process used gas tungsten arc welding with variation of the amperage, that is 70 amperes or heat input calculated at 3.6 kJ per millimeter, 90 ampere or heat input calculated at 3.1 kJ per millimeter, 110 ampere or calculated heat input 2.9 kJ per millimeter. The result of the study, we evaluated the macroscopic of welding. As you can see in the diagram and the tables, that the dilution is higher in the lower heat input. This is due to the higher penetration in the lowest heat input by using the highest amperage, while the lowest amperage make it the dilution effect on the base metal is lower. The microstructure examination of the weld joint, the higher heat input makes the carbide precipitation higher. This is due to the high, when using the high heat input, the travel speed is lower. So the cooling down time is longer, and the formation of the grain has enough time to form the coarse grain. And in the stainless steel, the carbide is precipitating in the grain boundary. So therefore, higher heat input makes it higher carbide precipitation and bigger grain in the heat affected zone. The effect of heat input in the stainless steel 304 heat affected zone hardness is fluctuating regardless of the heat input. While in the T22, heat affected zone hardness is higher in the lower heat input. The reason for this is when the heat input is lower, the amperage is increased, therefore the temperature in the heat affected zone is increased. So the have some cooling effect in the heat affected zone. The Ferrite number value effect is proportional with the heat input. The higher heat input has a higher Ferrite number value. Ferrite number is lower than limit in the variation of heat input. So means all specimen is safe from tendency of hot cracks. As a note, stainless steel with a lower Ferrite number value has better corrosion resistance than stainless steel with higher Ferrite number value. As a conclusion, dilution is higher in the lower heat input. Highest hardness value is in the layers number 2 and in the roots, because when in the layers number 1, there are some multi-layer welding effect or tempering effect. The heat input has a characteristic that the lowest heat input make the hardness of heat affected zone in the 304 and hardness heat affected zone in the low alloy steel is increased. Heat input also proportional with the Ferrite number. Lowest heat input than the lowest Ferrite number. So this is the conclusion of our study. Thank you for your attention.